Welcome to quidprosequo, where creativity meets academia. Here, we're all about leveraging our love of academia to improve both your creative writing practice and ours. Whether you're honing your craft or just beginning your writing journey, we're here to share scholarly insights, inspiration, and advice that benefits us all. Let's get started.
Welcome to our first course of quidprosequo's 2025 season, Planetary Science for World Builders. I'm Zach.
And I'm Rin.
As part of our specialization into a podcast that brings academic research to creative writing, we are pivoting to a series format that we are calling courses. Courses will consist of several episodes based on academic research addressing one theme. We're also borrowing an element from the Writing Excuses podcast, and at the end of every episode, we'll have a bit of homework to prompt your creativity. Where we're diverging from writing excuses is that we're going to start each episode with an example of the homework from the previous episode. This means that we could end up reading your work on the podcast. So be sure to leave a comment on the episode or send us an email at quidprosequo@gmail.com to get your responses showcased on the podcast.
Something we're also looking to do at the end of each course is to present a case study. And we are actually going to do at least two case studies per course, and one will be a traditionally published book, and the other will be an indie published book. So indie authors, if you're listening, we would love to promote your book if it's relevant to the course that we're on. So we'll be putting information out on our social media, and we would love to have you submit. Our Planetary Science for World Building course draws on Zach's background as an astronomer and his experience teaching planetary science in a university setting. We're going to talk about stars, planetary systems, moons, rings, and galaxies, and how you can use this research in your world building. Obviously, this series sounds like it's a lot more for sci-fi people than for fantasy people, but fantasy people definitely stick around, because whether you're writing technical or hard science fiction or general softer science fiction, this series will introduce you to some of the research you can consider when deciding where habitable planets go in your setting. Even if you're not writing about a setting where the characters are visiting different planets or star systems or galaxies, this research can present new opportunities for what your main world can look like. So fantasy readers, that's why you should stick around.
Yeah, I'm working on a longer version of this argument to post over on my Substack, but here's the short version. I hope this series will correct something that Marie Brennan noted in her book New Worlds, Volume 1. Many fantasy settings don't play with astronomy like they could. Most fantasy settings assume a sun-like star, one moon, and an Earth-like planet, and there is so much more variety in the universe that you can play with. And this course should open your mind to alternate possibilities of what your world or worlds may look like. One last preliminary comment. Astronomy is somewhat unique in that astronomers usually publish their papers, their code, and their data on public websites that the public can use for free. That means that this series will be unique in how much primary source scientific material is available if you want to familiarize yourself with the literature. Many of these papers are heavy on jargon, so they may be difficult to understand, but feel free to reach out to me if you want to chat about an astronomy paper that you want to understand. You can reach me on social media at dcwinters or via email at dcwinters@gmail.com.
Awesome. With that, let's get started talking about stars and star systems. As far as astronomers are concerned, there are three kinds of stuff in the universe: hydrogen, helium, and then everything else. Hydrogen and helium exist in the universe naturally, but everything else has to be made by a star. That's where the idea of being made of stardust comes from. All the material in your body was inside a star at some point. The same is true of the air you breathe and the phone you're using to listen to this podcast, or computer, or whatever you're using.
It's easy to think that all stars are the same because they seem pretty similar when you look at the night sky, just little dots of light. But it turns out that there are lots of different kinds of stars, and we group them into types, and we assign a letter to describe each type.
These types were created by a woman named Annie Jump Cannon. She was an astronomer at Harvard that grouped stars based on the colors of light they emit. Later, astronomers found out that Cannon's types were associated with the temperature of the stars as well as how much matter was in them, how much stuff is in them, otherwise known as mass. We now know that the color and temperature are determined by how massive a star is.
From most massive to least massive, the stellar types are O, B, A, F, G, K, and M. O stars are big, they're blue, and they are hot, while M stars are small, red, and cold, at least compared to other stars. Our sun is a G-type star, so it's somewhere in the middle. As a side note, the objects that I study as part of my doctorate research have less mass than M stars and fall into three more types, L, T, and Y. Besides color and temperature, it turns out that a third aspect of a star is also determined by its mass, its lifetime.
So, just like most things in the universe, stars have life cycles. They begin as protostars and clouds of gas and dust, then spend most of their lives calmly turning hydrogen and helium into stardust. Scientists refer to this age of a stellar life as the main sequence, which is relatively calm compared to the other stages of stellar life cycles. That being said, stars do change over time. For example, our sun has gotten brighter and hotter since it started on the main sequence.
The death of stars is an interesting topic, though here we're only going to talk briefly about them since we're ultimately talking about world building, and you will see very shortly that worlds and stellar death do not go together. When large stars die, they explode in supernovae, and they release a ton of energy. Some supernovae release more energy than an entire galaxy does when it's just normally spinning along. All of that energy would destroy any planets around that star. So we'll end our discussion there about stellar deaths. But there is a lot more that we could talk about.
Awesome. And don't forget, you can reach out to Zach if you want to talk about this more, because Zach loves talking about this stuff.
I do.
Yeah. So smaller stars will have gentler deaths, where their top layers expand and then fly away from the star, leaving a glowing ember of stardust called a white dwarf. They'll spend billions of years sending their energy into space as light, and some planets have even been found around white dwarfs.
Stars generally are not floating through space on their own. They are surrounded by other things like planets, asteroids, comets, and other stars. In fact, many stars have one or more companion stars.
So does one star orbit the other like a planet?
Well, when you have two stars that are close together, they form a binary pair. Each star in the pair is going to orbit what's called the center of mass. And that's the point where if you were to make like a giant seesaw, giant cosmic seesaw, the point where the two stars balance each other is the center of mass. When you add a third star, the system will collapse unless the third star is far enough away from the other two. Then it will orbit that binary like a planet. If you add a fourth star, you start to get options. You could have something like a triple system, but with another star orbiting very far away from the center. So you have two stars orbiting around the binary. Or you could have two binary pairs orbiting each other, but also orbiting around their shared center of mass. The more stars you add, the rarer the system is, and the more options there are for how to nest your stars. But there does come a point where, in order to get a stable system, you end up with stars that are too far apart to orbit each other, and then they form separate systems. Scientists have found several thousand stable configurations for systems with 3 stars in them apart from the configurations that we've described. However, these configurations require precise initial conditions. If you were to put all the possible initial conditions for 3 stars in a hat and draw one, or even a lot of them, randomly, the near infinite number of possible configurations drown out to the 10,000 some odd that are stable, meaning you probably won't find them in nature, but they are interesting cases to consider for fiction. I would recommend looking up the Wikipedia page on the 3-body problem to see some diagrams of what these more complicated orbits would look like.
So at this point, we've talked a lot about stars. Let's move on to planets. Astronomers have found that other stars have planets just like the sun. Planets come in 2 categories: rocky planets like the Earth and Mars, and gas planets like Jupiter and Saturn. Most world builders focus on rocky planets because that's where life as we know it can exist.
As far as we know, life requires water. This means that the hotter the star, the further away from the star your planet will need to be to have liquid water. Scientists call the region where liquid water can exist the habitable zone, and it's a ring that goes around the star. You can break down rocky planets into 4 categories based on where they are in relation to the habitable zone. The first are the uninhabitable planets, which are outside of the habitable zone entirely. These are planets like Mercury. You could also have desert planets, and they're on the hot side of the habitable zone. These would include planets like Arrakis from Dune and Tatooine from Star Wars. Next, you have Earth-like planets, which sit comfortably inside of the habitable zone, so they'll have lots of variety. And then finally, you have ice planets, which lie on the cold side of the habitable zone. These would be like Hoth from Star Wars. There is a fourth type of planet to consider. Scientists called these Hycean worlds, and Hycean is a combination of the words hydrogen and ocean. A Hycean planet is a planet that is larger than Earth, so it's been able to hold on to an atmosphere that's mostly made out of hydrogen, like the gas giants, but it's covered in an ocean of liquid water. Hycean worlds have never been observed so far, but they are theoretically interesting objects that scientists have been studying for a while now, and they'd be an interesting thing to throw into your world building. Let's complicate our discussion about the habitable zone by talking about two factors which can complicate whether a planet will actually be habitable. The first is stellar activity, and the second one is tides. We've already mentioned that stars are relatively calm when they are on the main sequence, but they do tend to act up, and sometimes they shoot off material into space. The closer you are to a star, the higher the risk that you will be impacted by stellar variability. As an example, if the host star shoots off a piece of itself into space, being closer means it's more likely to hit you, and if it does, it's more likely to have higher energy than if you were far away. If you have life on a planet like that, it could get baked or radiated with a ton of radiation, which would make it difficult to live there. The second factor is tides. We normally think about tides when we're talking about the moon, and we'll talk about that more when we get to moons inside of the next episode, but stars also exert tides on planets. Tides are caused by the difference in the gravitational force felt by one side of the planet compared to the other side of the planet. This leads the planet to be squished, and it also causes rotation to slow down. In most cases, Venus is an exception. If a planet is orbiting really close to its home star, it's likely its rotation will have slowed to the point where the same side of the planet is always facing the star. This will produce one side that is hot, one side that is cold, and a temperate band that will be in what's often called perpetual twilight. So if you're putting a planet around an M dwarf, so one of those really small red stars, when we talk about stellar systems, we're often interested in talking about how many planets there are inside of the system and what kinds of planets they are. We used to assume, because of the way that the solar system is set up, that smaller rocky planets would form closer to stars and then larger gas giants would form further away, since the hot temperatures near the middle of the system would push the gas out towards the edges. But recent research is challenging this assumption. There's a paper which we will link in the description that showed that most of the multiplanetary systems we have found so far are made up of planets that have similar masses. This means that our solar system is actually kind of unique and strange in that way. Again, we're continuing to learn more about multiplanetary systems, so as we find more of them, this might change. So this is definitely something to pay attention to as more research comes out.
So in systems with multiple stars, every star in a system is going to have its own habitable zone. Depending on how far away the stars are, you might have planets that could orbit one star and not the other, or planets that orbit both stars. If two stars are close enough, they may act as one star and have a shared habitable zone, which would be more oval-shaped than a normal habitable zone.
If you have a planet that orbits one star and not the other, day and night will have more to do with the time of year, as we normally understand a year, than with the rotation of the planet. At some points of the year, the planet is going to be between the two stars, and so it won't have any night, because once it spins around from one star, it'll be facing the other star. At other points, the planet will be opposite the two stars and will have a night as it spins. When the two stars pass in front of each other, they'll eclipse each other, and the planet will cool off, just like it does on Earth when we have a solar eclipse. This eclipse thing will also be true if the planet orbits both of the planets at once.
When it comes to asteroids and comets, we only have our own solar system to go off of because these objects are much too small and faint for scientists to see with our current telescopes. As far as we know, comets form a shell around the system. Ours, for example, is called the Oort cloud. Did I say that right?
Yep.
Awesome. Meanwhile, both comets and asteroids form belts. Our solar system has one belt between Mars and Jupiter and another belt outside of Neptune's orbit. Asteroids also tend to clump up slightly ahead and behind massive planets due to the interaction between the gravity of the planet and the gravity of the star. All of this is probably true of other systems with a single star, but in a binary star system, things will be more complicated.
In the solar system, everything is aligned in a disk. So all of the planets are orbiting in the same disk around the sun. Though there are some binary systems with rings that orbit perpendicularly to how the stars orbit each other. If those words don't make sense, you can think of this like spinning a yo-yo while riding a merry-go-round. The direction that the merry-go-round spins is akin to the direction that the stars are spinning, while the yo-yo is spinning in a direction that is akin to how these polar rings, is the word that is used for them, would be spinning.
Let me explain that in even more layperson terms, because I had to think through that a bit. So you have, if everything is operating on the x-axis, then the rings are going to be in the y-axis, or vice versa. Yeah.
Right.
Okay. Cool. So we've covered a lot in this episode, so let's talk about how you might use what we've talked about to inform your world building. First, you could put your planet around a different kind of star. From a scientific standpoint, it makes the most sense to be around stars like the sun or colder, but you don't have to be bound by science when you're writing fiction. That's the fun part.
As another suggestion for something that you could play with as far as the type of star is concerned, you could put a planet around a white dwarf. This could be really interesting if it's one of those ancient progenitor sci-fi empires that often pop up inside of science fiction books. And speaking of progenitor species and empires, you could use a really strange system architecture as a kind of cosmic beacon, showing that there was or that there is life inside of a particular system. If there is a system architecture which is very different from the architecture that we expect, it could be evidence for alien life.
You could also put your planet in a binary system. A couple minutes ago, we talked a bit about how that would change the cycle of day and night, as well as how one star eclipsing the other would make your world colder while the eclipse is ongoing. If your planet is orbiting in the opposite direction that the stars are orbiting each other, so that idea of the X versus the Y axis, like what Rin talked about, you're not going to have an eclipse like that. So you'll be able to see the stars at all times. If you are talking about planets inside of more complicated systems, then it becomes more complicated. If you're talking about a triple system, depending on where you put your planet, you might be able to see a bright but still faint star inside of the night sky at certain points, or you may be able to see the binary at certain points inside of the night sky as well. As is the case in astronomy, many times the answer is it depends.
Yeah. If you have a world where spaceships are moving between planets, you can put asteroid and comet belts between different planets to be an obstacle on this journey. For example, I'm working on a sci-fi right now, and today I texted Zach because I knew we had this series coming up, and I knew he would have a good answer for me. I was like, can you hide a small planet in an asteroid belt? And he told me, yes, I could. You could hide a dwarf planet, and it would be relatively hard to find, and it served the purpose of my world perfectly. And honestly, if he told me it was not feasible, I was probably still going to do it because this is a soft sci-fi.
Right.
It's really more science fantasy than hard science fiction. But there's so many fun things you can do with space, and we are going to get into that more in our satellites episode, right, Zach?
Yes. We're going to, when we get to satellites, we're going to be talking about moons and ring systems, which is going to be a lot of fun. And then we will talk about galaxies and what galaxies can tell us about habitability, as well as what the night sky might look like on your planet. For now, I'm going to talk to you about our homework assignment for next time. It comes in 2 parts. The first is to play with some of the ideas that we presented here and design a planetary system. Once you've done that, we want you to list some of the sensory details that your characters inside of this system would encounter in their everyday life that manifests that structure. So if you were doing something with the binary stars, tell us about the eclipses. Or if there aren't eclipses, tell us why.
That sounds like such a fun homework assignment. Personally, my goal is to write up my homework assignment and post on my Substack, which is just ckjensenauthor.substack.com, I think. So I'm posting mine on Substack. We want you to post yours in the comments or email us to quidprosequo@gmail.com. We would love to read your work on the podcast. Zach, do you have anything else for us today?
I don't think so.
Thank you so much for joining us. We'll see you next time on Quid Pros Quo.
Quid Pros Quo is hosted by DC Winters and CK Jensen. If you liked this episode, please subscribe and leave us a rating on Spotify, Apple Podcasts, or wherever you get your podcasts. If you'd like to contact us, you can email us at quidprosequo@gmail.com. Thank you for joining us today.